The Persian Gulf in August runs at the edge of what the human body can sustain outdoors without intervention. Surface water temperature reaches 34 degrees Celsius in the shallower reaches of the northern Gulf, and the air above it carries a moisture load that makes the distinction between breathing and drinking largely theoretical. In the confined sea lanes of the Gulf Approach Corridor, where the Strait of Hormuz funnels the traffic of the world's oil supply through a gap 54 kilometers wide at its narrowest. The heat is a constant, and the confined geometry of the waterway is a tactical reality that both sides understand equally well. USS Mahan makes 17 knots on a northwesterly heading, 31 nautical miles southeast of Bandar Abbas, operating as the close escort for a commercial LNG carrier transiting to the Kuwaiti terminal. She has been at general quarters for 9 minutes, since the EW operator classified a dense cluster of small craft radar signatures emerging from the Iranian coast near Keshem Island. 14 contacts, each between 12 and 18 meters, moving at 35 to 42 knots on an intercepting bearing. The IRGCN fast patrol boat swarm is a known operational concept. Mass and dispersion as the answer to a technologically superior surface combatant. The Mahan's operational response is to engage the closest craft with the gun mount while maneuvering to maintain distance. The gun mount is engaging. The small arms teams are on the bridge wings. What the EW operator does not classify immediately is the 15th contact. It left Keshem Island 18 minutes before the swarm, moving at only 6 knots. Slow enough to avoid radar classification as a fast patrol profile. 11 meters long, 3.4 tons, a 2-person crew. Its forward cargo hold contains 840 kilograms of ANFO, ammonium nitrate/fuel oil explosive, detonated by a simple trigger held by the helmsman. It is not a missile. It is a boat. It has been moving slowly enough and at a low enough radar cross-section that it has not been separated from the background clutter of the coastline. It reaches the Mahan at 2:47:09 a.m., approaching from the port quarter, while the gun mount and the ship's attention are on the swarm to starboard. The craft impacts the port hull at frame 73, approximately 0.6 meters above the waterline. Not a below waterline impact, not a penetration of the engineering spaces. Frame 73 is the aft section of the ship's hangar bay, the space designed to shelter and service the ship's embarked MH-60 helicopter. The ANFO detonation at 2:47:09 a.m. tears a hole approximately 1.8 meters by 2.3 meters in the port hull and drives the detonation, overpressure, and fragmentation through the hull into the hangar bay. The MH-60 helicopter is in the hangar bay. It has been there since the ship entered the transit corridor 3 hours ago, secured to the hangar deck by tie-down chains, main rotor blades folded, all fuel systems in the ground configuration. The helicopter contains approximately 1,200 liters of JP-8 aviation turbine fuel in its main tank, at the maximum pre-departure fuel load that was topped off before the transit began. JP-8 has a flash point of 38 degrees Celsius, in an ambient environment of 34 degrees Celsius and an enclosed hangar bay that runs 5 to 8 degrees hotter than outside air. The JP-8 vapor pressure in the hangar bay is already near its lower flammable limit before any ignition source arrives. The fragmentation from the ANFO detonation provides approximately 400 ignition sources simultaneously. The fire in the hangar bay begins at 2:47:10 a.m., 1 second after the detonation. The JP-8 vapors ignite across the entire hangar bay simultaneously in a deflagration. A rapid combustion front propagating through the vapor-air mixture faster than a flame can be tracked visually. The crew members in the hangar bay at the time of the detonation, 2 aviation boatswain's mates conducting a pre-transit equipment check, are knocked off their feet by the overpressure of the ANFO detonation, and then engulfed by the JP-8 deflagration. Both sustain severe burns to exposed skin and are evacuated from the hangar bay through the aft hangar door by the first responders who arrive at 2:47:38 a.m. Both are alive. The medical officer receives them in the ship's medical space at 2:47:55 a.m. In DC Central, the fire alarm for the hangar bay activates at 2:47:12 a.m. The AFFF fixed suppression system for the hangar bay activates automatically at 2:47:14 a.m. The hangar bay suppression system is set to automatic activation on fire alarm because the helicopter is a JP-8 fuel hazard. And the design intent is that the suppression system responds faster than a human can assess and authorize. The AFFF suppression system consists of a network of spray nozzles in the hangar overhead, connected to the ship's AFFF storage system, fed at 65 pounds per square inch operating pressure. The AFFF activation begins at 2:47:14 a.m. Foam begins flowing from the hangar overhead nozzles. The fire, which has been burning for 4 seconds and has involved the helicopter's exterior surfaces, the hangar deck JP-8 pooling from the ruptured fuel tank, and the hangar's composite and aluminum interior fittings, receives the foam application. The foam begins to suppress the fire at the deck level where the pooled JP-8 is burning. At 2:48:03 a.m., 49 seconds after the AFFF activation, the flow rate from the hangar overhead nozzles drops to approximately 18% of the designed flow rate. The foam that was covering the fire at deck level is now applied as a thin trickle rather than a flood. The JP-8 pool fire that was being suppressed by the foam coverage is no longer covered. The thin application is insufficient to maintain the foam blanket on a burning JP-8 pool at hangar bay temperatures. The fire reestablishes at the pool locations. In DC Central, the AFFF system pressure gauge for the hangar bay circuit drops from 65 psi to 11 psi at 2:48:03 a.m. The chief engineer reads it at 2:48:06 a.m., 3 seconds after the drop. His first assumption is a rupture in the AFFF supply line. He calls the supply valve location. Check the hangar bay AFFF supply valve for physical damage or rupture. Report immediately. The report comes back at 2:48:31 a.m. The AFFF supply line to the hangar bay is intact. The supply valve is open. The pressure upstream of the valve is 64 pounds per square inch, normal. The pressure downstream at the hangar bay nozzle system is 11 pounds per square inch. The pressure drop is across the nozzle feed manifold, not in the supply line. He pulls the AFFF system schematic from the DC Central drawing rack. Between the pressure gauge tap and the manifold input is a flexible hose connection. A 2-inch braided stainless steel flexible section that allows for thermal expansion in the AFFF line. The flexible section is inside the AFFF storage compartment bulkhead penetration behind structural steel, not visible from any inspection point. The schematic shows it. The maintenance records show the last physical inspection of that flexible section was 14 months ago. The replacement interval is 24 months. The AFFF system for the hangar bay is draining not to the hangar bay, but through the failed flexible connection behind the storage compartment bulkhead. Into the bilge. The hangar bay nozzles are receiving 11 pounds per square inch, because that is all the partially drained tank can push through the leak path. The AFFF storage tank has been losing approximately 85 liters per minute since the system activated at 2:47:14 a.m. The tank holds 1,400 liters at full charge. At the current drain rate, the tank will be empty in approximately 15 minutes. But the effective delivery to the fire is 18% of design, grossly insufficient for a JP-8 pool fire. The 15 minutes of remaining supply is irrelevant if the delivery rate cannot be restored. The hangar bay AFFF system feeds from the ship's central AFFF storage through a dedicated manifold that serves only the hangar bay circuit. The manifold has 2 inputs: the primary AFFF storage tank connection and a cross-connect from the main firefighting foam bus that can be opened to supplement the hangar bay supply if the primary tank runs low. Opening the cross-connect will divert from the main bus reserve 4,200 liters shared across all ship systems, but will restore some pressure to the hangar bay circuit. He calculates. Main bus pressure is 70 pounds per square inch, with the leak draining 85 liters per minute. The cross-connect will raise hangar bay circuit pressure to approximately 28 pounds per square inch. 43% of design, not ideal. Above the minimum effective rate for a confined space with a JP8 pool fire below the nozzle array. He opens the cross-connect from DC Central at 2:48:52 a.m. He calls the hangar bay fire team simultaneously. Hangar bay fire team, DC Central. The AFFF system is compromised. You are receiving approximately 43% of designed flow due to a line failure behind the storage compartment. The pool fire will not be fully suppressed by the overhead system. I need you to supplement with portable AFFF from the hangar bay locker and seawater from the fire main hose station at frame 72. Apply seawater to the hangar deck perimeter to contain the pool boundary. Then apply portable AFFF to the pool surface in sections. You have approximately 2 minutes before the pool fire begins heating the overhead structure to critical temperatures. Confirm you have the portable AFFF from the locker. The hangar bay damage control locker contains 4 13-liter portable AFFF extinguishers, each with a discharge time of approximately 45 seconds at the designed application rate. 4 extinguishers, 180 seconds of portable foam. The team leader confirms at 2:49:11 a.m. The fire team, 6 personnel in full SCBA gear and proximity suits, enters the hangar bay at 2:49:18 a.m. through the starboard hangar door, which is the upwind side of the space relative to the fire. The port hull breach is visible as a ragged opening at frame 73. The fire is a pool of burning JP8 approximately 3 meters by 4 meters centered under the helicopter's fuel tank location, with flames reaching 2.5 to 3 meters and secondary flames running up the helicopter's port side where the fuel lines from the ruptured tank have been feeding fuel down the airframe. The overhead AFFF nozzles are operating, visible as a fine mist from approximately 12 spray points. But the coverage is clearly insufficient. The foam is consumed by the fire faster than it is applied. The team leader deploys the fire main hose to the hangar deck perimeter. Seawater does not suppress JP8 fire. It floats on JP8 and can spread the burning fuel if applied directly to the pool, but applied to the deck surfaces surrounding the pool. Seawater cools the steel, creates a water barrier that contains the pool boundary, and prevents the pool from expanding toward the hangar doors and the fuel storage compartment aft of the hangar. This is its purpose here. The hose operator, standing in the hangar doorway at the edge of the thermal radiation from the burning pool, maintains the application in steady, sweeping arcs across the deck perimeter, keeping the water film on surfaces that are heating rapidly from the pool fire's radiant output. In the Gulf ambient temperature of 34 degrees Celsius, with the hangar bay already running hotter than ambient before the fire, the steel of the hangar deck would reach JP8 auto ignition temperature within approximately 6 minutes of sustained pool fire exposure without this cooling. The hose operator's job is to prevent that timeline from arriving before the portable extinguishers can do their work. The first portable AFFF extinguisher is applied to the forward section of the JP8 pool at 2:49:44 a.m. The foam immediately begins forming a blanket over the fuel surface in the forward section. Approximately 1 meter by 1 meter of coverage before the 13-liter extinguisher is exhausted at 2:50:29 a.m. The blanket holds on the forward section. Fire suppressed. The second extinguisher is applied to the center section at 2:50:35 a.m. The third to the aft section at 2:51:22 a.m. Each application suppresses approximately 1 square meter of pool surface. 3 of the 4 portable extinguishers have been used. The pool fire is approximately 60% suppressed. The forward and center sections have foam blankets that are holding. The aft section, nearest the hull breach, is still burning. The overhead AFFF system, running at 43% of design flow through the cross-connect, is maintaining the foam blanket on the suppressed sections by continuous application. If the overhead system is secured or fails further, the sustained sections will reignite within 90 seconds. The aft pool section, approximately 1 meter by 1.2 meters, still burning, closest to the hull breach, requires the 4th portable extinguisher. But the 4th extinguisher is the last one in the hangar bay locker. Once it is discharged, there is no more portable AFFF in the hangar bay. The team leader calls DC Central at 2:51:44 a.m. 4th extinguisher, last one. Do I apply it to the aft section or hold it as emergency reserve? I have approximately 1 square meter of active pool fire at the aft section. Overhead is sustaining the other 2 sections. If the aft section extends before I apply, I lose containment. The chief engineer responds in 14 seconds. Apply the 4th extinguisher to the aft section. Overhead at current flow will sustain the blanket if the foam is applied in the next 60 seconds. The deck temperature in the aft section is not yet above the JP8 reignition threshold. The hull breach is providing cooling airflow to that section from the Gulf air. If you wait, the deck temperature will climb above that threshold, and the overhead flow rate will be insufficient to maintain suppression even after you apply the portable. Apply now. The 4th portable extinguisher is applied to the aft pool section at 2:51:58 a.m. Foam covers the aft section. The fire in the aft section is suppressed at 2:52:11 a.m., 13 seconds after application. The entire JP8 pool fire is now under foam blanket. The overhead system at 43% flow is maintaining coverage across all 3 sections. The helicopter structural fire, the composite and aluminum airframe surfaces, is being addressed by the team with the fire main hose, washing down surfaces that are still holding heat and preventing reignition. The hangar bay fire is declared controlled at 2:54:03 a.m. The word is controlled, not extinguished. The overhead AFFF system is still running. The foam blanket on the deck is being maintained by the overhead at 43% flow. The helicopter airframe is no longer actively burning. The hull breach at frame 73 is open to the Gulf air, helping ventilate the space, but also introducing warm air that slightly raises the deck temperature and the JP8 vapor pressure. The team remains in the space for the reflash watch period, 30 minutes minimum, at 2:57:19 a.m. The failed flexible AFFF hose section in the storage compartment bulkhead penetration is physically accessed by the damage controlman, who cuts through the non-structural cover panel with a reciprocating saw from the damage control locker. The failed flexible section is visible. A 2-inch braided stainless hose, 35 centimeters long, with a longitudinal crack in the inner liner that has been pumping foam into the bilge since the system activated. The liner failure is a fatigue crack, developing over the service life of the hose and reaching propagation at the elevated pressure of the emergency activation. The section could not be seen from any external inspection point. The maintenance schedule specified a 24-month physical replacement regardless of condition. The section was 14 months into that interval. The failed section is isolated at 2:57:44 a.m. by closing the isolation valves on either side of the penetration assembly. The AFFF pressure to the hangar bay circuit rises immediately to 61 pounds per square inch as the leak path is closed. The overhead nozzle flow rate rises to 94% of design. The foam blanket on the hangar deck stabilizes at full coverage. The reflash risk decreases substantially. AFFF main bus consumption at 2:58:30 a.m. The cross-connect has drawn approximately 400 liters from the main bus since opening at 2:48:52 a.m. Remaining main bus reserve, approximately 3,800 liters. Adequate. The hangar bay reflash watch period completes at 3:24:03 a.m. without incident. Fire confirmed, extinguished. 37 minutes after the initial detonation. The JP-8 pool residue on the hangar deck, approximately 180 liters of the helicopter's original 1,200-liter fuel load that did not burn, is removed by absorbent pad. The helicopter is a total loss. The composite airframe has sustained thermal damage beyond structural repair, and the fire and ANFO fragmentation damage to the avionics and drive systems are confirmed at 100% replacement requirement. The hull breach at frame 73 is patched with a steel plate backed by structural adhesive at 3:41 a.m. The breach was above the waterline. No flooding. One IRGCN vessel with 840 kilograms ANFO detonated against the port hull at frame 73, 0.6 meters above the waterline at 2:47:09 a.m. Hangar Bay JP-8 pool fire began at 2:47:10 a.m. AFFF automatic activation at 2:47:14 a.m. AFFF supply line flexible hose failure identified at 2:48:06 a.m., reducing hangar bay AFFF delivery to 18% of design. Elapsed time from activation to failure, 49 seconds. Cross-connect to main bus opened at 2:48:52 a.m., restoring delivery to 43%. 4 portable AFFF extinguishers applied in sequence. Forward section suppressed at 2:50:29 a.m., center at 2:51:22 a.m., aft at 2:52:11 a.m. Fire controlled at 2:54:03 a.m. Failed flexible hose section isolated at 2:57:44 a.m., restoring AFFF to 94%. Reflash watch completed without incident at 3:24:03 a.m. Fire extinguished, 36 minutes and 49 seconds from ignition. Main bus AFFF consumed. Approximately 400 liters of 4,200-liter reserve. 2 personnel, severe burns, treated and stable. Helicopter, total loss. Hull breach, patched above waterline. Ship status, operational. The post-event AFFF system audit, conducted at Bahrain over 3 days following the Mahan's return, inspected every flexible hose section in every AFFF circuit aboard the ship. 12 flexible sections were found to have inner liner cracking at varying degrees of progression. None had yet reached propagation, but 4 were assessed as within 6 months of failure under normal operational cycling. All 12 were replaced. The maintenance interval for flexible AFFF hose sections was revised from 24 months to 12 months for ships operating in the Gulf, where the combination of ambient heat, humidity, and elevated internal pressure cycling from frequent system testing accelerates liner fatigue. The chief engineer was asked at the debrief whether the cross-connect decision had been difficult. He said no. He said the cross-connect is designed for exactly this type of supplementation, and the main bus reserve is sized to accommodate it. The only actual decision at 2:48:52 a.m. was whether the cross-connect would provide enough additional pressure to make the overhead system useful rather than decorative. He calculated that 28 pounds per square inch was approximately 43% of the 65 pounds per square inch design pressure. Not ideal, but above the minimum effective application rate for the overhead system in a confined space, with a JP-8 pool fire below the nozzle array. He said 43% is uncomfortable. He said 43% is more than zero. He was asked about the 4th portable extinguisher decision, whether to apply it or hold it. He said the key variable was deck temperature at the aft section. If the deck temperature had reached 60 degrees Celsius, The fourth extinguisher would have been insufficient to establish a stable blanket regardless of when it was applied. The deck temperature at the aft section was not yet at that threshold when he gave the authorization, because the hull breach was providing some cooling airflow to that section from the Gulf air outside. He said the breach that caused the fire was also the thing that allowed the fire to be controlled. He paused. Then he said, "The flexible hose section is 14 months old. The interval is 24 months. It failed because the inner liner of a braided stainless hose in the Gulf environment degrades faster than the design assumption." He said the design assumption was made for a temperate climate maintenance environment. The Gulf is not temperate. He said the lesson is not about the fire. The fire was managed. The lesson is about the 14-month-old hose that was not inspected because the schedule said it had 10 more months before it needed to be inspected. He said a schedule is a minimum, not a ceiling. The flexible hose section that failed, 35 centimeters of braided stainless AFFF line, removed from the penetration at 2:57:44 a.m., is in the Naval Sea Systems Command's Material Failure Archive. It is cataloged and preserved as a reference specimen for the revised maintenance interval guidance. The crack in its inner liner is 7.3 centimeters long. It was enough.